So these are all the components for our dice kit laid out before us. Just have a quick check all the components that you need are there, and you've got enough solder and masking tape to start. Take the orange brown resistors first. They are orange brown gold, and bend the legs down 90 degrees to form a staple shape, which should be just right to go over the two holes either side of where it says 330. There are 7 such resistors to put in, and I'll do 2 at this pace. So hold each resistor once you've pushed it into place with some masking tape, as close to the board as it will go. Then turn the board over so that you're on the solder side, and a hot soldering iron touch down onto the pad, and then from the other side melt some soldering, just a small amount of solder, and I haven't done it there but I'll do it on this one. As you move the solder iron away, draw it up the leg of the resistor to form or help form the characteristic volcano shape. Just redone that first one. Okay, so I'll repeat that again. There is a couple of legs that need cutting off now, so I'm going to pick up the wire cutters. The wire cutters should be used with the open face uppermost and the flat face down, and cut the leg off at the top of the volcano as close as you can. Remove the tape. Resistor 1 done. So I'll do another one at this pace. Bend the legs down 90 degrees. Orange brown gold, and I'm going to place it in the same way so that the gold bands are on the right. It doesn't make any difference to how the resistor works, but it just looks better. Remember, hold it in place with tape so it doesn't move. Turn over and solder. Hot tip down onto the pad. Solder in from the side. Melt a small amount. A couple of seconds and wipe up the leg. Melt. Let it heat up and then wipe up the leg. Snip off at the top of the volcano. Discard those legs and remove the tape. 2 done. Okay, taking the pace up a bit. There are 7 330 ohm resistors to do in total. 4 in this line here, and then 3 more dotted around the board where they could fit them. So I've gone for gold bands on the right where they're horizontal, and there are a couple of vertical ones to finish, and I usually put gold bands at the bottom if the resistor is vertical. Just to repeat, it doesn't matter to the resistor which way round it goes, but it just looks better if you keep all the gold bands lined up. Okay, back to a more sedate pace. There are 3 more resistors to go in. The first 2 are going to be 10,000 ohms, 10k, and their colour banding is brown, black, orange, gold, and there are 2 of them. One marked, both marked 10k, the locations for them, so it's pretty straightforward how to locate them. Do them the same way. Tape to hold them in place. Melt some solder, wipe up the leg. Remove the tape and move on. Again, gold bands on the right for the horizontal. There's another 10k there. Brown, black, orange, gold. I struggle slightly to get this one in. It's not the neatest positioning of a resistor over that. And the final resistor is a 22k resistor. There's only one of them in the kit, so So it should be a unique, I think it's red, orange, gold, if my memory serves. Gold band on the right. Bit of tape to hold it in place. Solder. Cut as much of that leg off as you can, so there's nothing that's going to be a bit stabby when you've finished. Right, now a couple of components which you might not recognise. The first one is a push switch. It's a push to make switch, and it only goes in one way round. You can't get it the wrong way round. It goes in both ways and it just fits. And it clicks down into place, and it doesn't really need tape because it's clicked in place. And the download socket, and this goes in up there, and it has a very firm positive click as you push it firmly in. The plastic lugs seem to lock it in place. Now there are 4 solder joints here, and 1, 2, 3, 4, 5 solder joints on the download socket. 2 of them are very close together on both sides, and it doesn't matter if your solder joint lobs across to each other on there. It's one of the few times it doesn't matter if this occurs. In fact, it's rather difficult to do it without the solder joints joining. I've decided my board is moving around too much, and I'm going to put a bit of masking tape to stop it floating about. So just up there are 2 together. It's the same pin, and it really doesn't matter if it blobs across like mine has there. That's fine. Same on the other side, there's 2 more, and again, if that solder joint joins one next to it, that's absolutely fine in this location. So we end up with kind of 3 solder joints, and then on the switch it's 4 separate solder joints. Very easy, nothing to cut off, there's no long legs to remove, just solder what's poking through the holes. Still trying to fix that one, it's a little bit messy, that one, not my finest. Just moving solder around a little bit. Be careful you don't overheat at this point. If you see something like that, I know exactly how much heat you can apply, but if you're a beginner you can overdo things. Next component is the download socket. Now there is a little notch shown at the top there, and that's replicated with the plastic component, a similar notch, and one should fit over the other. The notch should go over the notch. Now this is very easy to knock if you don't use some masking tape, and very, very carefully take this down so it doesn't move during the solder process. There are 8 pins very close together. Now unlike the download socket, very important that all 8 pins remain separate to each other and no solder joints flow into one another. They've got to be 8 separate solder joints. The pins are very small, but the gap is sufficient that with a steady hand and a bit of practice that you've had before, you should be able to achieve these 8 solder joints without any of them flowing together. If you did get a solder joint crossing across to another one, making a bridge across, simply wipe your hot soldering iron between the 2 legs and try and recreate the gap. It should be quite a simple task just to remove a little bit of solder if you do put too much on. So that is now the socket that's going to hold the microcontroller, and I'm going to place the microcontroller in to keep it safe. Now we've stopped heating. The reason we don't solder the microcontroller directly into the holes is because the heat could damage it. So we solder that socket first, and then any heat's gone. Next it is the LEDs. Now notice the LEDs have a long leg, as I'm holding it at the top, and a shorter leg, and the long leg goes into the hole above and the shorter leg below, and that's the same for all 7. Make sure you click it down firmly onto the board, and just like the resistors, do them one at a time. Bit of masking tape. Even though it's clicked in place, masking tape will stop it moving as you do the soldering. Now treat these same as the resistors, but be absolutely critical about not applying too much heat, doing this as quickly as you can, and this is why we've left them to the end. They're the most heat sensitive component and the one that you can damage by over soldering. So no more than 3 seconds as you're trying to solder each leg. Any more than 3 seconds and you could burn the LED out and it won't work. Okay, speeding things up. All 7 LEDs go in the same way, with the longer leg of the LED at the top and the shorter leg in the hole below. If you put them in the wrong way around, they simply won't work. Okay, slowing down now, because the last thing is this power connector for the battery. Now there are a couple of holes marked 0 volts and plus volts. It should be red in the plus volts and black for 0 volts, but there are a couple of holes nearby which we're going to use to stop this cable from getting pulled out all the time. So we're going to use them to take the strain. So down through that further away hole, and then push both cable wires up through the one next to it, and finally solder into the holes. It should be black into 0 volts and red into plus volts. However, in my haste I get this bit wrong and put the red wire in the 0 volt hole and solder it in. I know, I've made a mistake. Well, I'm about to make a mistake. Yeah, so the solder is normal, there's nothing to cut off, but at this point turning it over, put it in the wrong hole. So I need to desolder that now, which is quite simple. You basically reheat the solder joint and pull the wire out. The only problem is it could leave some solder in that hole, which is going to make it difficult for getting the next wire in. And I've left a blob of solder on the wire as well, so it won't go into the correct hole anymore. So a bit of a nightmare. Just take your time, try and get things right. So the red wire goes into the plus volt. So I'm just going to knock that bit of solder off with my hot iron. And that will go into the correct hole. Correcting mistakes is quite tricky in electronics. It's so much better to do things right first time, obviously. Take your time, double check. So check twice, solder once would be a good rule of thumb. Now I've got a bit of solder in that hole, so I'm going to have to do some creative work to get rid of it using a solder vacuum pump, which I have done off camera. And I'm going to finally solder and lose the picture. So that's it. There, we're back on now. That's the dice finished. All the components have been added. We just need now to program the microcontroller. Just tidying up those cables, pulling it through, and you can see that that system takes the strain and stops the solder joints being broken. Completed.